Forgive my moment of frustration, ladies and gentlemen, that you just heard. So picking back up. So this is continuing with the boiling video. So, boiling point for a liquid is the temperature at which atmospheric pressure equals vapor pressure. And we said for water, we're not boiling at room temperature because the vapor pressure at 25 Celsius is 23.8 millimeters of mercury. The atmospheric pressure is gargantuan compared to that. So they're not equal, so we're not boiling. Well, we said that usually, under common conditions, requires us to input heat because we know as we increase temperature, we can always increase vapor pressure. So, if we input energy, we're going to increase this, increase this, increase this, increase this. When these two are equal, then we boil. And the vapor pressure of water at 100 degrees Celsius is 760 millimeters of mercury. So that is why, to get these two things to be equal, occurs at 100 degrees Celsius if this is my atmospheric pressure. And that is why the boiling point, under common conditions, we know is 100. But can we boil water at other temperatures? Well, these need to be true and equal for boiling. Could we decrease atmospheric pressure? And yes, we can in a vacuum. So if we would put a beaker of water in a vacuum and then remove the air from above, we are decreasing the number of collisions, keeps getting lower and lower and lower and lower and lower. And you can boil whenever the pressure of the atmosphere is equal to 23.8 millimeters of mercury, and that is vapor pressure of water at 25, you're going to boil. So you will see rapid throughout the whole liquid vapor being created, and it'll escape. Now, does the water, the liquid, feel hot? It's at 25 Celsius. It will be at room temperature. Now, as soon as we stop the vacuum pump, you know that some air is going to creep in and immediately cease the boiling. So we really need the aid of a vacuum to be able to do that. But of course, the other thing that we could do is take this beaker of water to a higher elevation. So at higher elevations, we know atmospheric pressure decreases. So here are some references. In an airplane, about 6,000 meters above sea level, we're going to boil at 79 Celsius. Well, I always wonder, common reference points. So in Denver, Colorado, so the mile-high city, it's about a mile above sea level or so, and water boils at 97 Celsius. So if you ever read high altitude directions on baking products, they're often having you change the temperature or add other leavening ingredients and so on because of the change in the boiling temperature of water. Well, what about Mount Everest, the highest mountain in the world? So it's an elevation about 9,000 meters. Well, we're going to boil about 70 Celsius. So you could try to boil an egg, and this is not going to be successful. You don't have the heat content to be able to denature the proteins. So your water may be boiling, but it's not going to accomplish the cooking for you. Could we get water to boil above 100? And you sure can. The Dead Sea is actually the lowest point in the world. You're negative 400 meters below sea level. You're going to boil at 101.4 degrees Celsius. Of course, hospital autoclaves that, clean, fully clean, and sterilize surgical equipment, well, those use the enhancement of atmospheric pressure. So they're getting a situation where we're increasing atmospheric pressure. So we're going to have to input much, much more energy to get these to be equal So we can definitely have the boiling point above 100 as well as below 100. So hopefully we have a better understanding of boiling. It's controlled much more by pressures than it is by heat, interestingly enough.